Supplying a 115 volts alternating current motor with 208 volts alternating current does not meet National Electrical Code requirements. NEC Section 210.11 code requires that electrical equipment shall be installed and used according to any instructions included in the listing or labeling. In the described scenario, the motor is labeled for 115 volts alternating current operation, but it is being supplied with 208 volts alternating current. This directly violates the manufacturer's instructions and therefore is a code violation. Furthermore, the motor is not wired correctly, as two of the phases are not landed. This can result in improper operation of the motor, potentially leading to reduced performance, overheating, or premature failure. The use of a 208 volts alternating current electrical plug for a 115 volts alternating current motor is also a violation and presents a significant safety hazard. It increases the risk of electrical shock or fire due to the mismatch in voltage and the potential for incorrect connections. To rectify the situation, firstly, replace the motor with one that is specifically rated for 208 volts alternating current operation. This ensures that the equipment is compatible with the available supply voltage. Secondly, ensure that the motor is wired correctly with all three phases properly landed and connected according to the manufacturer's specifications. This ensures proper operation and prevents potential damage to the motor. Thirdly, use an appropriate electrical plug that is compatible with the voltage rating of the motor. This prevents the risk of electrical shock or fire. The correct approach involves firstly verifying the voltage rating of the motor. This can be found on the motor's nameplate, which should clearly indicate the required supply voltage. Secondly, confirming the supply voltage at the point of connection. Use a voltmeter to measure the voltage at the outlet or junction box where the motor will be connected. Thirdly, selecting a motor that matches the supply voltage. If the motor's voltage rating does not match the supply voltage, it is essential to replace it with a motor that is compatible. Fourthly, wiring the motor correctly. Follow the manufacturer's instructions for wiring the motor, ensuring that all phases are properly connected. Fifthly, using the correct plug and receptacle. Use a plug and receptacle that are specifically designed for the voltage and current requirements of the motor. This prevents the risk of electrical shock or fire. Failing to adhere to these guidelines can result in several potential problems. Firstly, equipment damage. Supplying a motor with the wrong voltage can cause it to overheat, burn out, or otherwise fail prematurely. Secondly, safety hazards. Incorrect wiring or the use of incompatible plugs and receptacles can create a risk of electrical shock or fire. Thirdly, code violations. Violating NEC requirements can result in fines, penalties, or even the shutdown of operations. It is important to consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and standards. This helps to ensure the safety and reliability of the electrical system. The National Electrical Code provides comprehensive guidelines for electrical installations, including requirements for motor installations. Adhering to these guidelines is essential for ensuring the safety and proper operation of electrical equipment. The use of appropriately rated components, correct wiring practices, and adherence to manufacturer's instructions are all critical aspects of a safe and code-compliant electrical installation. In summary, the scenario described violates NEC code and poses significant safety and operational risks. Corrective actions include replacing the motor with a 208 volts alternating current rated unit, ensuring proper wiring, and using a compatible electrical plug. Consulting with a qualified electrician is highly recommended to ensure compliance with all applicable codes and standards. The implications of using a motor wired in such a way that it is undervolted include reduced torque. Motors are designed to operate at a specific voltage. When the voltage supplied is lower than the rated voltage, the motor's ability to produce torque is significantly reduced. This can lead to the motor struggling to start or maintain speed, especially under load. Overheating is another risk. An undervolted motor will draw more current to compensate for the lower voltage in an attempt to maintain the required power output. This increased current flow can cause the motor windings to overheat, potentially damaging the insulation and leading to premature failure. Efficiency is also affected. Motors operate most efficiently at their rated voltage. When undervolted, the motor's efficiency decreases, meaning it consumes more energy to perform the same amount of work. Reduced lifespan is a concern. The increased heat and stress on the motor components due to undervoltage operation can significantly reduce the motor's lifespan. Voltage imbalance can occur. In three-phase systems, if one or more phases are not properly connected, it can create a voltage imbalance. This imbalance can lead to uneven current distribution, causing some phases to overheat while others are underutilized. Vibration and noise is another potential problem. Undervoltage operation can cause the motor to vibrate excessively and generate more noise due to the increased mechanical stress. Control issues are also possible. The motor's control system, if any, may not function correctly under undervoltage conditions, leading to erratic behavior or failure to start. It is important to ensure that the motor's voltage rating matches the supply voltage to avoid these problems and ensure safe and efficient operation. The importance of nameplate data on a motor includes voltage rating. This indicates the voltage at which the motor is designed to operate. Operating the motor at a different voltage can lead to performance issues, damage, or safety hazards. Current rating is another important factor. This indicates the maximum current the motor is designed to draw under normal operating conditions. Exceeding this current can cause overheating and damage to the motor. Horsepower is also key. This indicates the mechanical power the motor can produce. It is important for selecting a motor that is appropriately sized for the application. Speed is another nameplate data consideration. This indicates the motor's rotational speed, typically in revolutions per minute. It is important for matching the motor to the driven equipment. Frequency is also shown on the nameplate, indicating the frequency of the alternating current power supply for which the motor is designed, typically 50 Hz or 60 Hz. Phase is indicated as well. This indicates whether the motor is designed for single-phase or three-phase power. Insulation class is crucial. This indicates the maximum temperature the motor's insulation can withstand. It is important for selecting a motor that is suitable for the operating environment. Duty cycle is displayed on the nameplate. This indicates the motor's operating time, such as continuous or intermittent. It is important for selecting a motor that can handle the demands of the application. Frame size is also relevant, indicating the physical dimensions of the motor. It is important for ensuring that the motor will fit in the available space. Enclosure type is another nameplate consideration, indicating the degree of protection the motor provides against environmental factors such as dust and moisture. It is important for selecting a motor that is suitable for the operating environment. Understanding and adhering to the nameplate data is crucial for safe and efficient motor operation. It helps to prevent damage to the motor, ensure proper performance, and avoid safety hazards. Regarding the dangers of incorrect phase connections on a three-phase motor, one major issue is reverse rotation. If the phases are connected incorrectly, the motor will rotate in the opposite direction from what is intended. This can damage the driven equipment or create safety hazards. Overheating is another consideration. Incorrect phase connections can cause the motor to draw excessive current, leading to overheating and potential damage to the windings. Vibration is also a potential outcome. Incorrect phase connections can cause the motor to vibrate excessively, which can damage the motor and the driven equipment. Reduced torque can also be an issue. Incorrect phase connections can reduce the motor's torque output, making it difficult for it to start or operate under load. Imbalance is a major threat as well. Incorrect phase connections can create a voltage imbalance in the motor, which can lead to uneven current distribution and overheating. Winding damage is a risk. The uneven current distribution caused by incorrect phase connections can damage the motor windings, leading to premature failure. Control issues are also possible. The motor's control system may not function correctly with incorrect phase connections, leading to erratic behavior or failure to start. Safety hazards are present. Incorrect phase connections can create a risk of electrical shock or fire. It is important to ensure that the phases are connected correctly to avoid these problems and ensure safe and efficient motor operation. The process of checking and correcting phase rotation involves firstly de-energizing the circuit. Before working on any electrical equipment, to energize the circuit to prevent electrical shock. Secondly, identifying the phases. Use a phase rotation tester to identify the phases of the power supply. Thirdly, connecting the motor leads. Connect the motor leads to the power supply, ensuring that the phases are connected in the correct sequence. Fourthly, verifying the rotation. Briefly energize the motor and observe the direction of rotation. Fifthly, correcting the rotation if necessary. If the motor is rotating in the wrong direction, de-energize the circuit and swap any two of the phase connections. Sixthly, testing again. Energize the motor again and verify that it is rotating in the correct direction. Seventhly, securing the connections. Once the motor is rotating in the correct direction, secure all of the connections. Eighthly, documenting the changes. Document any changes that were made to the wiring. Phase rotation testers are used to determine the sequence of the phases in a three-phase power system. They typically use a set of lights or a meter to indicate the direction of phase rotation. It is important to use a phase rotation tester that is rated for the voltage of the power system being tested. Proper phase rotation is essential for the correct operation of three-phase motors and other equipment. The potential consequences of running a motor with the wrong voltage include insulation breakdown. Overvoltage can stress the motor's insulation, leading to premature breakdown and failure. Reduced lifespan is another risk factor. Operating a motor outside of its rated voltage range can shorten its lifespan. Overheating, again, is a problem. Both overvoltage and undervoltage can cause the motor to overheat, leading to damage. Inefficient operation is a possibility. Operating a motor outside of its rated voltage range can reduce its efficiency, wasting energy. Reduced torque output can also occur. Undervoltage can reduce the motor's torque output, making it difficult to start or operate under load. Control issues are a consideration. The motor's control system may not function correctly with the wrong voltage, leading to erratic behavior or failure to start. Safety hazards are present in this type of scenario. Operating a motor with the wrong voltage can create a risk of electrical shock or fire. It is important to ensure that the motor is operated within its rated voltage range to avoid these problems and ensure safe and efficient operation. Regarding the types of electrical plugs and receptacles, and their voltage and amperage ratings, National Electrical Manufacturers Association, or NEMA, configurations define the standard for plugs and receptacles in North America. These configurations are identified by a number followed by letters indicating the type of device, the number of poles, and the amperage and voltage ratings. Straight blade plugs and receptacles are commonly used for general purpose applications, such as powering lamps and small appliances. They are typically rated for 15 amps or 20 amps at 125 volts. Locking plugs and receptacles are used for more demanding applications, such as powering tools and equipment in industrial settings. They feature a locking mechanism that prevents accidental disconnection. Twist-lock plugs and receptacles are a common type of locking connector. They are typically rated for 20 amps, 30 amps, or 50 amps at 125 volts, 250 volts, or 600 volts. Pin and sleeve devices are used for high current applications, such as powering welders and generators. They feature a robust design that can withstand harsh environments. They are typically rated for 30 amps, 60 amps, or 100 amps at 250 volts or 600 volts. It is important to select the correct plug and receptacle for the application to ensure safe and reliable operation. The plug and receptacle must be rated for the voltage and current requirements of the equipment being powered. It is also important to ensure that the plug and receptacle are properly grounded to prevent electrical shock. Adapters should be avoided, as they can create a safety hazard. Using the correct plug and receptacle is crucial for preventing electrical shock and fire. It is also important to follow all applicable electrical codes and regulations. The correct way to measure voltage at a receptacle involves firstly, using a digital multimeter. A digital multimeter, or DMM, is a versatile tool that can be used to measure voltage, current, and resistance. Secondly, setting the DMM to the correct voltage range. Select the appropriate voltage range on the DMM. For measuring 120 volts alternating current, select a range that is slightly higher, such as 200 volts alternating current. Thirdly, inserting the probes into the receptacle. Insert the black probe into the neutral slot and the red probe into the hot slot. Fourthly, reading the voltage measurement. Read the voltage measurement on the DMM display. The voltage should be within the acceptable range, typically 110 volts to 125 volts for a 120 volt circuit. Fifthly, testing multiple receptacles. Test multiple receptacles in the area to ensure that the voltage is consistent. Safety precautions should always be a priority when measuring voltage. Wear safety glasses to protect your eyes from potential hazards. Use a DMM with insulated probes to prevent electrical shock. Avoid touching any bare wires or metal pots while measuring voltage. If the voltage is not within the acceptable range, contact a qualified electrician to investigate the problem. Measuring voltage at a receptacle is a simple task, but it is important to take safety precautions. If the voltage is not within the acceptable range, contact a qualified electrician to investigate the problem. If a motor is under load and not operating at full load amperage, it could be due to several reasons. Firstly, the load on the motor may be less than its rated capacity. The motor is designed to deliver a certain amount of power, and if the load is less than that, the motor will draw less current. Secondly, the voltage supplied to the motor may be lower than its rated voltage. This can reduce the motor's torque output and cause it to draw less current. Thirdly, the motor may be oversized for the application. If the motor is larger than necessary, it will not be fully loaded and will draw less current. Fourthly, the motor may be operating at a reduced speed. This can reduce the motor's power output and cause it to draw less current. Fifthly, the motor's efficiency may be higher than expected. This can reduce the amount of current the motor needs to draw to deliver the required power. It is important to investigate the cause of the low amperage to ensure that the motor is operating properly and efficiently. If the motor is not fully loaded, it may be possible to downsize it to a smaller motor. If the voltage is low, it may be necessary to increase the voltage supplied to the motor. If the motor is operating at a reduced speed, it may be necessary to increase the speed. It is important to consult with a qualified electrician or motor specialist to determine the best course of action. Operating a motor under load, but below its full load amperage, is not necessarily a problem, but it is important to understand the reasons why this is happening. This helps to ensure that the motor is operating efficiently and reliably. The purpose of NEC Article 430 is to provide requirements for the application and installation of motors, motor circuits, and motor control equipment. Article 430 covers a wide range of topics related to motors, including motor circuit conductors, motor overload protection, motor short circuit and ground fault protection, motor disconnecting means, motor control circuits, and motor control centers. The goal of Article 430 is to ensure the safe and reliable operation of motors and motor circuits. It provides requirements for selecting the correct conductors, overcurrent protection devices, and disconnecting means for motor circuits. It also provides requirements for protecting motors from overload, short circuits, and ground faults. Article 430 is an important resource for electricians, engineers, and other professionals who work with motors and motor circuits. It provides the information needed to design and install motor circuits that are safer and compliant with the National Electrical Code. The scope of Article 430 includes all types of motors, including single-phase motors, three-phase motors, direct current motors, and synchronous motors. It also includes all types of motor control equipment, including motor starters, motor controllers, and motor control centers. Article 430 is a comprehensive set of requirements for the application and installation of motors and motor circuits. It is essential for anyone who works with motors to be familiar with the requirements of Article 430. Regarding equipment listing and labeling, Underwriters Laboratories, or UL, is an independent, not-for-profit organization that tests and certifies products for safety. Products that have been tested and certified by UL are marked with the UL listing mark. The UL listing mark indicates that the product meets UL safety standards. Electrical Testing Laboratories, or ETL, is another independent testing and certification organization. Products that have been tested and certified by ETL are marked with the ETL listing mark. The ETL listing mark indicates that the product meets ETL safety standards. Canadian Standards Association, or CSA, is a Canadian organization that tests and certifies products for safety. Products that have been tested and certified by CSA are marked with the CSA listing mark. The CSA listing mark indicates that the product meets CSA safety standards. The listing and labeling of electrical equipment is important for ensuring that the equipment is safe and meets applicable standards. The listing mark indicates that the equipment has been tested and certified by an independent organization. The labeling provides information about the equipment's voltage, current, and other ratings. It is important to select electrical equipment that is listed and labeled by a recognized organization. This helps to ensure that the equipment is safe and meets applicable standards. The electrical equipment should be installed and used in accordance with the manufacturer's instructions. The manufacturer's instructions provide information about the equipment's installation, operation, and maintenance. It is important to follow the manufacturer's instructions to ensure that the equipment is installed and used safely and properly. NEC Section 110.3b states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This requirement is intended to ensure that electrical equipment is installed and used safely and properly. The listing and labeling of electrical equipment provides important information about the equipment's safety and performance. It is important to select electrical equipment that is listed and labeled by a recognized organization and to install and use the equipment in accordance with the manufacturer's instructions.